Welcome back to the next section on our statistics lecture. This time, we will talk about data. What is data? Data are pieces of information that can be collected from our selected samples. Data is the most essential thing that we can gather from research, and it has to be accurate, precise, and reliable. Fancy statistical methods cannot rescue garbage data, so collect exact values whenever possible, because that can be a major cause of error. This data is obtained from research instruments. In that sense, our research instruments must be validated by professionals in order for us to collect and to generate reliable, accurate data. At the highest level, two kinds of data exist. This is the quantitative data and the qualitative data. Quantitative data deals with numbers and things that we can measure objectively. Dimensions such as height, width, and length, temperature and humidity, prices, area, and volume. While on the other hand, qualitative data deals with characteristics and descriptors that can't be easily measured but can be observed subjectively, such as smells, tastes, textures, attractiveness, and color. Broadly speaking, when you measure something and give it a number value, you create quantitative data. But when you classify or judge something, you create qualitative data. Now let's talk in depth the quantitative data. It can be categorized into discrete quantitative, or the other one is the continuous quantitative data. For discrete quantitative data, these can be integers, indivisible entities, in example, kids and pets. For continuous quantitative data, it can be divided and reduced. For example, height in meters can be converted into centimeters and millimeters, or any unit that you desire. Another example to project the different type of quantitative data is if we have an individual tablet in a box. So these tablets are numbered in pieces. This is an example of discrete data. If I use a scale to measure the width of each tablet or weight of the entire box, that can be a continuous data. Continuous data can be used in many different kinds of hypothesis tests. For example, to assess the accuracy of the weight of our tablet or capsule, we could measure 30 boxes and perform a one sample t-test. So you have to decide what type of quantitative data you are going to collect from your research instrument. You may consult your statistician what is the needed or what type of quantitative data should you generate. Moving forward, let's have the qualitative data. This is categorized into three: binary, nominal, and ordinal. When you classify or categorize something, you create qualitative or attribute data. So the first one is binary data. This place things in one of two mutually exclusive categories. For example, choosing between right or being wrong, choosing true or false, or to accept or reject. Occasionally, if I get a box of capsule that contains a couple of individual pieces that are either too hard or too dry, if I went through the box and classified each piece as good or bad, that would be binary data. I could use this kind of data to develop a statistical model to predict how frequently I can expect to get a bad capsule. When collecting unordered or the nominal data, we assign individual items to name categories that do not have an implicit or natural value or rank. If I went through a box, for example, of a capsule again, and recorded the color of each in my worksheet, that would be a nominal data. This kind of data can be used in many different ways. For instance, I could use a chi-square to see if there is statistically significant difference in the amounts of each color of the capsule in a box. We also can have ordered or ordinal data, the last qualitative category, in which these items assigned into ordinal, it has categories that do not have implicit or natural order, such as short, medium, or tall. Another example is a survey question that asks us to rate an item on a scale of 1 to 10, with 10 being the best. That implies that 10 is better than 9, which is better than 8, and so on. Now let's have the level of measurement. So the level of measurement in our different types of data can be classified into nominal, ordinal, or interval. So for example, in a horse race, if you want to gather nominal data, your question would be stated like this: did this horse come in first place? So you will have a nominal data which should be answered by yes or no. If you want your data to be measured as ordinal, your manner of questioning should be rephrased. It should be stated, in what position did this horse finish? So the answer would be 1 for first, 2 for second, and 3 for third, and so on. If your data should be presented in an interval manner or in scale, the question should be rephrased into, how long did it take for this horse to finish? So the data that can be gathered is in seconds. For example, 60 seconds.